The James Webb Space Telescope has found evidence of human-like activity far from Earth, bringing us closer to answering the age-old question of whether we are alone in the universe. The search for extraterrestrial life has been a constant pursuit throughout human civilizations, generating thousands of literary works and scientific theories on the subject. Our fascination with our place in the universe, and the possibility that we are not alone, seems to be deeply ingrained in us, driving us to seek companionship, even if it is of extraterrestrial origin. We are getting closer and closer to finding the answers we have long desired. But are these answers truly what we seek? Or is there something deeper at play? In 2021, the James Webb Space Telescope posed a hypothetical question about the future capabilities of our technology. Could our telescopes detect artificial light on another planet, such as Proxima Centauri b? This exoplanet, the closest to Earth, lies in the habitable zone of our nearest neighboring star, Proxima Centauri, about 4.25 light-years away. Proxima Centauri b is believed to be locked in synchronous rotation, much like the Moon with Earth, with one side always facing its star. The possibility was raised that a technological civilization on Proxima Centauri b could transfer heat and electricity from the day side to the night side using photovoltaic cells that generate electricity from sunlight. Subsequently, a research paper, with Manasvi Lingam as one of the authors, showed that significant coverage of the daylight side with solar panels could be detected by future telescopes. Given that the James Webb Space Telescope represents a significant technological advancement, there is now a possibility that it can expand our search for possible artificial lights or habitable exoplanets such as Proxima Centauri b. Thanks to its increased sensitivity and range of capabilities, the James Webb Space Telescope may have discovered the light we have long been looking for, potentially propelling humanity toward another great leap in its evolution. But before we dive into the implications of this discovery, it is crucial to understand how this feat was possible. The James Webb Space Telescope mission explores the mysteries of Proxima Centauri b. Throughout history, humankind has sought answers to understand the fundamental questions about the universe, our existence, and our destiny. These common yet extremely difficult questions have fueled human curiosity for as long as we have been conscious. In the current era of exponential technological advancement, the question arises, are we any closer to finding those answers? A philosopher might argue that we are still in the early stages of understanding the universe and ourselves. Meanwhile, astronomers would be excited to share the latest discoveries about the cosmos using the advanced tools at their disposal. Although these advances often go unnoticed by the general public, they truly represent milestones in human evolution. Now, with a world literally at our fingertips, it is time to move forward and explore the universe in ways never before imagined. One of the most promising tools of exploration is the James Webb Space Telescope. This instrument, heir to the legacy of human space exploration, is destined to answer fundamental questions about our place in the cosmos. It has already begun to shed light on the possibility of life beyond our solar system, as evidenced by the recent discovery of potential artificial lights on a planet located light-years away. Proxima Centauri b, also known as Proxima b, is a super-Earth exoplanet orbiting an M-type star. These planets are more massive than Earth but lighter than ice giants like Neptune or Uranus, and they represent a unique class in the universe. Although much remains to be discovered and understood about Proxima b, this breakthrough represents a significant step forward in our quest to better comprehend our place in the cosmos. The first possible evidence of an exoplanet dates back to 1917, although at the time, it barely captured the attention and recognition of the scientific community. However, it was in 1992 that the first confirmed detection of an exoplanet astounded scientists. Since then, many others have been confirmed, with another notable example emerging in 2003. By April 1, 2024, a total of 5,653 exoplanets had been confirmed in 4,161 planetary systems, 196 of which contain more than one planet. These remarkable discoveries are mostly associated with M-type stars, also known as red dwarfs. Red dwarfs are the smallest stars on the main sequence and are considerably more common in the Milky Way than other types of stars. However, due to their low luminosity, observing them is not as easy as observing other stars. Red dwarfs have various classifications based on their temperature and size, often designated as M dwarfs. These stars, with surface temperatures of about 3,900 Kelvin, have specific characteristics that distinguish them. Proxima b has a mass estimated to be about 1.07 times that of Earth. Remarkably, it completes one full orbit around its star in only 11.2 Earth days, compared to our own planet's 365.25-day year. This gives us an estimate of the size and nature of Proxima B's star. The star's luminosity is surprisingly low across the electromagnetic spectrum, at only 0.16% of the Sun's total luminosity. In the visible spectrum, it is even dimmer, emitting just 0.056% of the Sun's light. More than 85% of its energy is emitted in the form of infrared radiation, and the planet orbits at a distance of about 0.04856 astronomical units from the star. The discovery of Proxima B was announced in 2016, raising the question: why has this particular exoplanet generated so much interest? One of the main reasons is that Proxima B is the closest known exoplanet to our Sun, albeit at a distance of 4.2 light-years, which is quite short on a cosmic scale. It is part of the triple star system known as Alpha Centauri. Despite its low luminosity, Proxima Centauri remains an object of great interest to astronomers. The Proxima Centauri system stands out as one of the brightest constellations in the night sky, ranking just behind Sirius and Procyon. However, the most intriguing thing about Proxima Centauri b is its potentially habitable position within the habitable zone of its star, a placement that suggests endless possibilities. This potential has led astronomers to embark on an expedition to explore the depths of its stellar significance. This is where the James Webb Space Telescope comes in. The four primary goals of the James Webb mission are to search for light from the first stars and galaxies that formed after the Big Bang, to study the formation and evolution of galaxies, to understand the formation of stars and planetary systems, and to investigate planetary systems and the origins of life. As the James Webb Space Telescope continues its exploration of exoplanets such as Proxima B, we move ever closer to achieving those goals. The search for extraterrestrial life is a particularly compelling area of space exploration. The search for extraterrestrial intelligence, SETI, project stems from the boundless curiosity of humanity, exploring all that moves and even all that does not. One could imagine a kind of cosmic treasure hunt, where instead of gold, we are searching for electromagnetic signals, potential whispers from civilizations beyond our wildest imagination. If you enjoyed this video, remember to like, subscribe, and turn on the notification bell. Thank you so much for watching.